cope with the situation because I have a lot of proof images to show you. But of course, in 20 minutes it's not possible to prove everything, and I don't have this material to change the pages, so I want to be very sketchy. So I will be sketchy if possible, because this problem is a very big cake. True contradiction is a very big cake in philosophy. So, first of all, I would like to pay your attention about this truth quotation, very famous quotations, of course. It's about the meaning of true value. What's the meaning of the logical value in general? So we have Frege, for instance. Frege says that the true value is a name. It's a reference of a proposition. And of course, a lot of different propositions can have exactly the same reference. So all of you know that, of course. And the point, according to me, in the end of the story, for this talk, I would like to say that it's possible to make sense of true contradictions, provided we say that the true value is a proper name or the reference of only one object. Not a class of sentences or a class of objects and propositions, but each true value is assigned to only one object. That's the only way, according to me, to make sense of true contradictions. That's the end, and here is the beginning. So, here we have distinction between the true and the false, of course. The false is everything is not the case, and the truth is everything is the case in an ontological view of true values. When you say being the case, the question is what is exactly being the case? What is the case? Is it a fact? Do you need something like ontology to account for your quotation on true values, etc.? That's the problem. This is a problem for philosophical logic. So here is my way to approach this problem. So we have 6 points in 20 minutes. No. So just have to be sketchy. So first, paraconsistency. The point is that according to Hartley Slater, in the paper from 95, paraconsistent logic. The question, according to Slater, there is no paraconsistent logic. It's not possible to have paraconsistent logic for at least 2 reasons, according to Slater. First, a paraconsistent logic is a logic in which, according to him, true contradictions can be accepted. So that's his way to say that paraconsistent logic makes sense. Of course, it's too hard to say that a paraconsistent logic is a logic in which there are true contradictions. Because a lot of different paraconsistent logics neither have true contradictions. A lot. Relevant logic or so on. According to Slater, true contradictions don't make sense. Okay. The question is, what is exactly the meaning of a true contradiction? You have to know the meaning of a contradiction. So in order to define the contradiction, you need different concepts from logic. You have to use the name of negation. Of course, a contradiction is supposed to be defined in terms of negation. You have to use the logical value, because according to Aristotle's principle, contradiction is a principle according to which it's not possible for a sentence in its negation to be both true. So you use negation and true are 2 different concepts as a way to define the principle of contradiction. So in order to know exactly what you mean by there are true contradictions, you have to know, first of all, what a negation is, and what is a true value, or what is truth as a true value logic. And then I have to present a point about oppositions, because oppositions is a relation between sentences, or maybe it can be a relation between objects. Maybe there is an opposition between you and me, because you are not me, and you are not me, and I'm not you, there is an opposition. So the logical way, the algebraic way to define an opposition is a good way to make sense of true contradictions. So that's the point. So first, Slater says this. Slater says, for instance, you have a sentence P. So the classical way to define negation is that if the value of P is false, so the value of not P is true, and the other way around, the equivalence. Okay, so if the negation of the true is the false, then the negation of the false is the true. But of course, Chris says that if you accept a paraconsistent negation, you can have true contradictions if you use a non-classical negation. But according to Slater, there is only one way to have a negation. The only one negation that exists is that negation is a contradiction-forming operation. So if you use negation in a logical system, you have a sentence P, you apply the negation on P, the result is the contradictory of P. That's a way of Slater defines negation. But of course, there is a lot of different negations that are not contradictory forming. For instance, we have intrusive negation is a stronger negation. Because with intrusive negation, you can say that, for instance, exclude middle doesn't hold, because if P is not true, the negation of P need not be true, and the other way around. And according to Slater, a paraconsistent negation is a negation such that a sentence and its negation can be both true. So that's a way to say that a contradiction may be true if we say that, for instance, just imagine that this is a paraconsistent negation, and we say it's possible for both this negation and sentence P not to entail the truth of Q. That's a way to define a paraconsistent system, to violate the principle of exclusion. So Slater, according to Slater say this operation that makes, that helps two propositions to be true at once is not a negation, that's something else. It's like Quine said, if you change the meaning, if you change the truth conditions of an operation, you change the subject, you change the topic. Was the point according to Quine. Priest says this is a proper negation. Slater says this is not a proper negation. So, for instance, the question is, what is exactly the meaning of negation? Negation is defined in terms of true value. So we say truth becomes a force, or the force of the negation becomes a true from a classical point of view. So if we change the model, if we change the way to define negation, you can have another constant, for instance. So Slater said, okay, if you change the meaning of the constant of negation, you can have both true sentences, but not in the sense of classical negation. So the point is that, according to Slater, Priest makes something like he lies, not lies, he cheats in his system LP, logic of paradox from 79. In this system, you can say, for instance, that a sentence is both true and false. So that's a value, proper value, paradoxical value. And according to this combination of bivalent true values, in this case, the negation of P means that, in this case, you have just the inversion of truth into false, and the inversion of false into true. So we have not true false, but false true. And of course, as a set, cannot take account of the order of the true values. So this is exactly the same value as this one. So just say that, according to Priest, this is designated value in classical logic. So this means that this proposition belongs to the set of designated value, and this one too, because of the same. So in this sense, we can say that true contradictions are true in this system, because we just say that this is a designated value. So Priest, Slater said, this is just a way to displace the problem, because according to Slater, a true contradiction doesn't mean that a sentence and its negation are both designated in the same model. According to Slater, true contradictions means that if the first sentence is accepted in the model, the second sentence is not accepted in the model. And of course, in this case, both true values are both accepted, they are designated. But if you say that by true contradictions, I mean that one sentence and its negation are both accepted and rejected at once, this is not the same as to say that both sentences are designated. So in this case, Slater says there is a conceptual problem with true contradictions. What is exactly the meaning of a true contradiction? You have to have a more abstract view of contradictions, because negation is not the same as a contradiction. And if you say that, for instance, according to Slater, contradiction means this one. So if you say that, for instance, P belongs to the model of language in which P is, in this case, the contradiction of P, just say that you have this sort of negation. Negation of P, according to Slater, is a negation in which P does not belong to the model. But the point is that with this sort of value, you can say that P and this negation, both sentences, belong in the same model. So Slater says, if they belong, these two sentences belong to the same model, this is not a contradiction. This is something else. So it's a way to say that Priest weakened the meaning of negation, or weakened the sense of a contradiction, when he says that two contradictions are possible. So, now the point is that, what do we mean exactly by logical value? It's possible to combine logical value. For instance, we can say that, as you have Belknap, for instance. In Belknap system, you have 4 different values in the Belknap system. In this case, you have only true and false, neither true nor false, and only false. So according to Slater, contradictions is not a connection of these two values. A contradiction is a conjunction of this one and this one. So we have a set of two different values, only true, only false. And this combination of two values is not the same as this one. This two values is first true value in LP. This combination of two values is, according to Slater, the meaning of contradiction. So according to Slater, the contradiction means that you can have these two values in one and the same model. So by making the difference between this sort of two values, Slater said it's not possible for a priest to assume, to go on saying that there are two contradictions. So combination of two values can go on, of course, because just think about maybe the system proposed by Schang inventing the generalized theory of true values. We can combine more and more different subsets and subsets of true values. And for instance, we can imagine that this sort of true value, the value in which we can say that the sentence is only true and true and false. You can imagine this sort of combination. The question is, does it make sense to have this sort of combination? Because for us, in classical logic, this combination doesn't make sense. But in many value logic, so to say, here we have a combination of only true and false. So, by combination, you can say that according to the meaning we give to a logical value, if you say that there are more than two true values, you can say that we can make sense of contradictions in such a chance system. But that just begs the point for Slater's point about contradiction, because according to Slater, it's only the same, because if you combine different true values, you stick with only two situations. Either you consider true values as accepted or rejected. If you say that a true value considered will represent something we reject, so we say that this true value is not in the model. If you accept this true value, this one, you say that the true values is in the model. So another way to define a contradiction, irrespective of true and false only, is that you say that a contradiction is a case in which you accept a true value and we reject at the same time a true value. So to say that a sentence is true and false is not the same that to say that we will accept the sentence and we reject at the same time. At the same time the sentence. So the meaning is not the same. So now about an opposition. Opposition has the first part. How many times do we have? 5 minutes?
6 minutes.
6 minutes? Okay, so now the question is, in order to have a clear sense of opposition, you have to construct a specific system. It's possible to construct this system. It says that an opposition is a relation between two objects. So these objects can be sentences, but any other objects in an ontology. So we have an ontology in which you say that each object is defined by a set of informations. You say that such and such an object have 2, 3, or 4 informations to be defined clearly. So here the opposition can be defined in 4 ways, for instance, according to the contradiction, the subcontrariety, the contrariety, and so on. The point is that here an opposition can be defined as the relation between this object and an opposite of this object. We say that, for instance, this object results from this operation. An operation turns this first object into another one, this one. So here you can say that according to this general definition, you say that an opposition is a relation between one term and its opposite. So here is an operation, it's being an opposite. So by means of this definition I gave the screen, but I just have to cope without this. I said that O can be defined as a sort of negation with different properties. So for instance, we can say that O behaves like a contradictory forming operator. We say that you behave, for instance, like a contradictory operator forming. If you say that, for instance, this sentence and this one cannot be accepted in the same model. Another way to define this set of operations is that both sentences can be accepted in the same model. Okay? So Slater says that this operator is just this one, CD. This means that if you want to create an opposite, there is only one sort of opposition according to Slater, an opposition by contradiction. Contradiction is the only way to make sense of negation. Okay, so if you say that O is negation, there is only one negation for Slater, this one, contradictory forming operator. But of course we can have a different way of combining or defining the way to turn an object to another one. Contradiction, by contrariety, by subcontrariety, and even by means of this operation you can say that, for instance, the relation of consequence can be seen as something like a double negation. A double mixed negation, because we have the consequence corresponds to subalternation in the square of opposition. Subalternation means that if you have this, so you have that. That's a relation of consequence from Tarskian point of view. And here we can say that consequence is sort of double negation. So everything can be defined in this framework for oppositions. So by means of this universal concept of opposition, so to say, you just abstract from the meaning of true value, true, false, both true and false, only true and both true and false, is a sort of combination of true values. And you can just implement this information into this system, and you obtain a sort of different sorts of opposite forming operators. And the question is it possible to find an operator such that this operator makes a sentence both accepted and rejected into the same model? That's an abstract question in order to answer to Slater's problem. So finally, the meaning of true contradictions means that, just imagine that a question is, do you accept this sentence? You say yes or no. Okay? So 1 for yes, 0 for no. Do you accept this sentence? If you say that you accept P, you say yes. If you don't accept P, you say no. Contradiction, according to Priest, both propositions are accepted. You say yes to the two propositions, you accept in the same way. But for Slater, again, the contradiction means that for one the same sentence, you answer yes and no at the same time. And to say yes and no about whether a sentence is true, for instance, is not the same as to say that one is the same sentence is true at the least and false at the least in Priest's system, in the logic of the four paradox. So and so on for the different meanings of combining true values, negation and opposition. So just in order to conclude, the point is to construct this logic of opposition in two ways. First, to define the relation between logical systems into a general framework in which each logical system is compared with another one. For instance, can we say that Clean's logic is contradictory to classical logic, or is it subcontrary to Clean's logic? How to compare the logic of Priest's paradox, for instance, with classical logic or intuitionist logic? We have a general framework in order to define the opposition between the systems. That's the meaning of opposition in this first way. So the meaning of opposition in this way, okay? You have an opposition between logical systems. Another way to define opposition is to say we want to have a definition of what an opposition is. In this case, you don't use this operator to define relation between systems. You want to have the very meaning of opposition in itself. It's exactly like in Tarski system, for instance. Tarski, we can use such theory to define the meaning of consequence as an operator or as a relation in terms of set theoretical relation between sets of sentences. And here we have exactly the same procedure. So the difference is that with an opposition, you have a different sort of properties to define, to given in order to define the concept of opposition. And according to me, just for the conclusion, the point is that there is only one way to make sense of true contradictions, is to introduce dialectical contradiction. Dialectical contradiction is a way to define a contradiction in the same way as in Hegelian ontology. But the point is that with Hegel's ontology, he says that everything comes from only one sentence. We have something like a model, and this model, everything is true. Okay? And we have a partition of this sentence, of this model, in different set of sentences. You say that there is only one true value in this model, everything is true, and then we partition this model into other sets of sets, in the sense that each of these sentences keep or conserve the initial true value being true. So that's the way Hegel says that, for instance, it's possible to have both true and true, because if you negate this sentence, you transform this sentence to another one, but this sentence conserves the true value of the initial model. That's the way in which Hegel wanted to say that it's possible to have both the truth of A and its continuation by the so-called concept of Aufhebung. Aufhebung, the Hegelian name, it means conservation, transformation by conservation. So this is a way to make sense of true contradictions, but that's a totally different ontology, a totally different way of defining true values. So that's the only way according to me to make sense of true contradictions. That's another ontology. So here are the different ways of making sense of the problem as a true contradictions by means of 5 different concepts. I try to make combination of these concepts on the screen. It's not very clear, of course. There's a lot of different things to talk about, combination of true values and so on. But I have to stop here. So,
thank you very much. We have some time for questions. Yeah.
There is a famous idea that Hegelian dialectics should be somehow employed in the logical sense, and I know of at least one theory that pretends to do that. Its name is dialogical logic, or dialogue logic, of Barthes and Robin.
Can you use his name again?
There is a famous book, From Axiom to Dialogue, of Elsa Barthes and Eric Krabbe, where they say that the idea they advocate in that book, dialogue logic, dialectical logic in some sense, this is a model that can be used to explain in the logical sense Hegelian dialectics. But can you say that it matches somehow with your idea of oppositional logic?
I don't know if this is book, so I'm not completely...
But it's based on Lorentzian constructive system, on operationalism. It makes logic like a two-player game. So in that sense...
in this presentation, or in what was supposed to be a presentation on the screen, I wanted to make use of algebraic logics. That is, you have a model. In a model, we have a set of sentences, and each set of sentences is assigned a true value. Okay? So according to me, in order to use algebraic logic to make sense of Hegel's dialectic systems, you say that we have only one model at the beginning. We have the truth, the absolute. Okay? The absolute is an object that is true because there is only one object in the world, so to say. And then, according to Hegel, we have something like a partition of the model into different parts of the model. And the point is that when you apply the concept of Aufhebung means you conserve the value of the object while transforming something in the object. So it becomes something different, but it conserves the identity of what it was in the beginning, so to say. I dislike the temporal version of Aufhebung, but it's a way to make sense of it. Okay? So in this case, we say that it's possible to accept and reject one the same sentence, because we say that, for instance, the sentence is different, at the same time it's identical to the first sentence. So that's a way for me to say that when Frege says that the true value is the denotation of a sentence, it's okay, but in an Hegelian system, you say that the true value is the denotation of only one object. Each object has only one true value, but each object conserves the same true value as the initial one. The truth, that's the absolute, the model. So everything shares something from the absolute model truth. That's a way to say that true contradictions make sense with an Hegelian ontology, in which the objects are not distinguished from the beginning. That's an algebraic way of defining Hegels. So I think that from an operationalist approach, it's somehow different.
Yeah, it seems that they go to construct that absolute,
yes,
and you are going to elaborate it.
Yeah, it's constructive. It's a partition by addition. You have one object, and 2, and 3, and 4 objects, and each object conserves the property of the initial object. It's a constructive way of defining the position. That's the way in which this operator is a constructive operator. The question is, how can we obtain another sentence, another information in a language by means of this operation? That's the point.
And in this system also, uttering a preposition or whatever, pointing to an object, it wouldn't be the same as saying that that's true. So we just reject that.
Here the value of this operation is not a true value, it's a bit string. A bit string will have a 1-0 set or set of 1-0 informations. You ask questions about an object, and the sort of the ordered sequence of bit strings you have gives you the meaning of the object. Okay? This is a logical value. But of course, in this sense, each object has only one string, only one logical value. But this logical value is a sort of true value, but each object has only one true value. There is no time to explain the difference between a true value or not value better. It says there's a difference between true values and not. It's wrong. I can't synthesize it.
Thank you.
So we do have time for a second short question and a short answer. If not, then let's thank the speaker again.